Animated logos are a compelling and ubiquitous way individuals and brands represent themselves online. Design tools currently offer templates and animation presets as ways to help novice designers animate logos. However, these solutions can be limited in their expressive range and do not necessarily adapt to every use case. In this paper, we present LogoMotion, an LLM-based method that automatically animates static layouts in a content-aware way. The first stage introduces multimodal LLM operators that take in visual context and construct a text representation of the canvas. Visual grounding is built through analysis of the logo layout, and animation code is implemented for each design element within it. The second stage introduces a technique for visually grounded program repair, which helps LLMs check what they have generated against the original layout specifications and debug differences in a targeted layer-wise fashion. We now walk through this approach in greater detail with an example of a logo for Cardinal skiing. So a user begins by taking their logo document into Illustrator and exporting it into an HTML page using a script. LogoMotion then augments this HTML with more semantic information. Every design element is captioned to provide an image description. For example, in this image, the person is captioned, "Icon of person skiing." Text values, bounding box information, and z-order are all automatically extracted during the export process. We then use an LLM to derive a visual hierarchy by classifying design elements as either a primary element, secondary element, text, or background. Primary elements were further analyzed for what direction they should come from, and secondary elements were grouped over to find elements that could time in together. This augmented HTML and image was then used to come up with a design concept. This natural language step mapped relevant animation actions to each element, for example, telling the skier here to slide in from one side as if skiing down a slope. Finally, we passed in the HTML, image, and design concept for an LLM to implement in animation code. Here are examples from a few runs of LogoMotion. Note that in this last run, the skier overshoots their final position due to a bug in the animation code. LLM-generated code is prone to unintended side effects, so we check and correct for visual bugs like these. We detected these bugs by going layer by layer and calculating bounding box differences between the last frame of animation and the target layout. If bugs were detected, the LLM was then prompted to return an isolated code snippet to fix the issue. Here is a correction of the earlier run. LogoMotion also had the ability to support interactive editing by taking user-prompted requests as code suggestions to fulfill. Similar to the program repair stage, GPT-4v would convert the requested change into an isolated portion of code that would be merged back into the original timeline. We conducted evaluations to understand the quality of LogoMotion centered around the following research questions. The first evaluation was a comparison study that compared LogoMotion against an ablated version of itself, as well as against Magic Animate, an industry standard for page-level animation. We found that LogoMotion was rated by design professionals to have significantly more relevance to the subject matter of the logos and comparable sequencing and execution to the industry standard. The strengths of LogoMotion were its ability to show motion that was characteristic of its subjects. Lanterns blew as if in wind, hockey sticks motioned as if in play, chess pieces moved down as if being set. Complex layouts could be animated in a logical and layer-aware way, and background elements could even be used effectively for storytelling. Lastly, to understand how usable novices could find LogoMotion, we showed novices its animated outputs and allowed them to edit through prompts. Novices generally like the logos as is, but could also rapidly customize them with ease and often found a logo publishable and improved after just 1 to 2 rounds of iteration.